everybody, I was getting the second cup of coffee, had an eye appointment this morning and ran a little bit late. I was like, can I get back? Can I get back? And the eye appointment, a little bit late, but good to see you here, Frank, Cassandra, Barrett, and Cassandra. We're going to get the assignments loaded up, just changing the audio volumes there. We've expanded the screen a little bit so I can reach around here a little bit more and you can see I'm staring at the screen. I don't know. We'll see if people like it or don't. Yeah, Barrett, you noticed the new haircut because it's been a busy week. It is, thank you, Barrett, right there, noticing. Got the haircut yesterday. So had eye appointment, haircut appointment, wedding appointment. That's what they call it, right? When you get married, it's a wedding appointment. Little music right here. And thank you, everybody. Sorry for the late start here. A little bit of a late start. And let me look at, it is busy day. We're going to get the questions loaded up here. We got a few questions already. So, going to meet with them at 1:20. So, we're going to do a tiny bit early because I'm meeting with a student at 1:20 on Discord. Let's see out here. Getting it all loaded up. But how are you doing today, Barrett? Thank you so much, Cassandra. I know. I hope it's a good. I like the haircut. Shout outs to, was it JC at Gold Star Barbers, I think. Shout outs to JC. So I'll show him and I'll send it to him. We were talking about video games and stuff, talking about Spider-Man. Man, if I can get my haircut and talk about video games and Spider-Man the whole time, that's a good haircut to me. And the haircut looks good. That's secondary to talking about video games and Spider-Man. We're loading up the environmental agency. We saw environmental agency question. Could you do the adults? Here, let's do it's adults graduate high school and environmental agency. So Statue 1, Chapter 13, environmental agencies. Stat 201, Chapter 13, Adults High School. I am good, got to sleep in. Oh, that's awesome. And haven't gotten through some assignments faster than I thought I would. Whoa, that's awesome. It's Thursday and I'm going to the Auburn Rodeo Saturday. Have fun at the rodeo. I don't know if I've ever been to a rodeo. I've been to a lot of things. Been to a Shania Twain concert. It's not a rodeo, but like the things I've been to, I stood outside a Marilyn Manson concert when he went to, like, I don't know. Like I didn't go to one. Went to a Bush concert growing up. Used to go to Volapalooza every year. Shout outs to Volapalooza. I'm trying to think who's Volapalooza this year. We've got the quiz loaded up in the background right here. So we've got the quiz loaded up. Make sure I have everything closed down of importance. But hopefully have fun at the rodeo, Barrett. That sounds awesome. Rodeo, I've never been. What should one expect when you go to rodeo? Junk mail question. Yeah, let's put the junk mail question on here. Men those in. We got environmental agency, adults high school, and then junk mail. Junk mail. There we go. So we're gonna we'll see which one we find first right here. Environmental agencies, adults high school. I just found the junk mail. Let's do the junk mail since we found it. Can you go chapter 3 and 2 about Philanthropic? You bet. Here, let me put Philanthropic on here. Thank you, Gwendolyn, for being here. We're going to do them as we find them. I've got a list of things right here. Philanthropic. So remember, follow along, help out. We found the junk mail one. All questions will be answered right here. 7 minutes in, just having some fun. Did the intro video for a little bit there. Here we go. Let's go do junk mail. To the main screen. Click the Hacker Man effect, and apparently logo went on the screen. So thank you so much, Barrett, right there. Fun times for the wedding coming up. So with this, we are going to open up a new Word document right here. And let's see, get my new Word document on the screen 2 hours later. Now, if you've ever done a problem with us here, what is the first thing we do whenever we get a problem? What is the very first thing we do whenever we get a problem? We get a problem and then we say, immediately we're going to mark this. Immediately we do this. These are the things you want to be thinking about when you work problems. You want to say, okay, immediately I'm going to get that notation, brother. Label the notation. If Leo was here, he'd say notation, brother. So a great job right there. Leo started that trend. Thank you, Leo. And so we're going to grab this right here. And I'll tell you what, I'll give you one for free because we got a lot of work to do today. We're going to mark the notation There's some things here that matter and some things that don't matter so much. That matters. We got some fun colors today. And this one does not matter so much. So they're trying to trick you a little bit. They're giving you extra information. This is X. That is N. And this is actually capital N, which does not stand for normally distributed. That's the size of the population. X is the number of successes. They get 131 responses from the recipients of the 10,050. Now we should know X over N. Someone tell me what that is. I'm going to calculate it here for you. But what in notation am I calculating? I'm seeing how many successes were there out of the sample. So can someone tell me in the chat, what am I calculating philosophically, theoretically right here? We're not doing philosophy. But what am I calculating? I'm calculating, you can tell me in words or notation, what is this value known as? It's how many successes out of the sample. Well, that is correct, Barrett. Good answers, Barrett. And so what is it? P hat, Barrett, all-star right there. P hat, that is the sample proportion. So in our sample, this many responded. Barrett, that's worth some 500 points. Great answers to Barrett. And this is what we need to do is find the notation. Now, as soon as we find P hat, anytime we find P hat, we're going to solve for what immediately? Anytime we solve for P hat, you should know, okay, I just found P hat. I'm going to immediately solve for what? It's just like, well, if you find that, might as well find about 87 something, 87.53. So Barrett on fire today. Great job, Barrett, right there. Q hat. So Q hat is 1 minus. It's just as simple as doing 1 minus. So it's going to be 0.8753. I think that's the rounded version of it. Just go here and take your answer and go 1 minus that. And there it is right there. It's 1, 2. So that rounds to 8. Those tens of thousands won't make too much of a difference, we hope. But still carry through. Frank, great answers, Frank. And so now, from here, we can make a confidence roll. You can do one prompt Z int on the calculator. If you don't have a TI calculator, that's all right. The math isn't too complicated. Let's look at the questions asking. The question asks, create a 95% confidence roll. Now, this is where we need to go to the David M. Lane site. Or if you know 1.96, you've already got it memorized. So we're going to go to the David M. Lane site. It's going to load up right here. And this is where you would go for the homeworks. Now, on the test, we would say to you, so watch what I click, here, and then enter 95. This is going to shade the middle 95. And on the test, we would say to you, use a z-score of 1.96 for a 95% confidence roll. So we would give this to you on the test. We don't expect you to memorize these. So if you had a 90%, it would be such. 98%, it'd be such. But the question wants 95. And once again, you would be given this on the test. We don't expect you to memorize them. We do expect you to know conceptually that if a larger z-score is used, that represents more confidence, and the z-score is part of the margin of error. So the z-score right here is part of the margin of error. Thank you, Mubot, telling everyone all those things. I'll tell it in the chat. Mubot, thank you. Mubot, thank you. He talks to us. He's always there in the background helping out. Thank you, Mubot. Oh, it didn't say. Very important I say this to him. There we go. Now it chats. Sometimes the chat breaks on me. All right, so we're going to plug in the numbers now. It just becomes a plug and chug problem right here. Thank you, Mubot. You are Mubot. And so we're going to put p hat right here. 1, 2, 4, 8. That's a nice number. A little kind of doubling of the numbers as we go. 1.96. That's the z-score. And square root 0.1248. And then times the complement 0.87. That's a decimal right there. 8752. Interesting how that one looks so different from the doubling. And then 1050. Make sure to carry your numbers as you go through this. If you notice right here, the z-score is associated with the 95% confidence. Usually a lot of people get stuck on this, but this is related to 95% confidence z-score. I think that's where a lot of the, wait, what do I do right here? How do I find the z-score? We would give it to you on the test, or you can go to the David M. Lane when doing the homeworks. It's just that, you know, z-scores are consistent. More on t's when we do t-scores. So now we go here and do 1.248. Well, I'm going to do the minus, because if I have it stored in here, I can do times that divided by 1050. This is what is called, well, I need to square root it. This is called the standard error, because this is the p hat times q hat over n square root. That's the standard error, which is just a measure of uncertainty or variation, and then 2 times it is the margin of error, or well, 1.96 is the margin of error for the 95% confidence interval. So for this, it's basically 2%. That rounds so beautifully to 2%, which makes our life super easy. Remember, it's 12.48%, so it'd be 10.48. Let's hope we did all the math right, to 14.48. Reason being is that p hat, and we'll put it on here on the screen at the same time, p hat is 12.48, and then this is plus or minus 2%. We times it by 100 because it's in a percentage, but it's 12.48 plus or minus 2% because the decimals on the margin of error, which is everything after the plus or minus, really rounds to 2 just about. We could also use the stat function on the, yes, definitely. The stat function, for those wanting to do it, the stat function is, well, that's not going to look good, is 1 prop z int. So stat 1 prop z int, and I had the, I brought up the videos yesterday. So if you're watching this and you have a TI calculator, you use 1 prop z int. Let me go put that in the chat. We won't watch the video today, but there, I found it because I have it in my Google search. Here's my video on it, the 1 prop z int. And it's a 1 minute and 30-second video in which I go through. So if you want, this is, I've watched the video. Yeah, it is. It's super great and it's super quick. But then if you know how to do it, because you might get p hat in the problem, so I do mention that, and it's super quick. You can, a lot of the remainder of this whole semester, Barrett, can be solved with the stat function on the calculator. It's super helpful, but we don't require to be able to have TIs. So glad you're watching that and solving that, Barrett, and thank you for mentioning that. Let's throw another 100 points because someone else might be able to go to this playlist and use, and this is pretty much everything we do. I made a video for pretty much all the TI things we use and some things we don't use because I went through and I think I just made videos for all of them. I was like, hey, why not? Got the TI emulator on my computer, so let's do it. I think we got those correct. Explain the interval to the company. Let's see here. Explain what the interval means. The company is 95% confident that the percentage of people who will respond, okay, yeah, that's it. That's I am 95% confident the true proportion of people who respond to the mailers contain the interval blank to blank. That's a better interpretation. I am 95% confident that the true proportion of people who will respond to the mailers contain the interval 10.48 to 14.48. Explain what 95% confidence means. This is your 95% of 95% confidence intervals are expected to contain the truth. And so we do have some notes open on that. I think this is it right here. 95 or 98, but 95% of 95% confidence intervals are expected to contain the true proportion. Whatever percent you want to talk about, you can sub that in. So of all the random sample sizes of this, we'll produce intervals that contain the truth. Pretty much a similar way of which we're saying it, that 95% confidence intervals, if you were to take repeated samples, 95% of 95% confidence intervals, repeated samples of that size would contain the truth. It's just to say that, like, what does this actually mean? It's not that we think one interval contains the truth. It's that if you were to repeatedly do this over time, and I think we show a graphic of that, if you were to repeatedly do this over time with different intervals, here's your intervals, 95% of these intervals over time would contain the truth. It's not that one interval contains the truth. It's that the repeated process, like law of large numbers, the more intervals you make, in the long run, 95% of your 95% confidence intervals would be expected to contain the parameter you're trying to estimate. The company must decide whether to do the mass mailing. Will they get it? Well, do you think the company, yes or no in the chat, do you think the company should think it's going to get a 6% return? They say, we need at least 6% to make this viable. If we get a 6% return, we're good. Would you tell them, pretty certain you're going to get a 6% return on this? Would you be pretty certain of that? So look at the interval right there and say, I'm 95% confident your return will be between 10.48 and 14.48%. Oh, yes, definitely, Barrett. Great work right there. More than certain on this because they should do the mass mailing. They should get that return. They want this return to do the mass mailing. And when you look at the interval, there's good evidence to believe the return will be contained in the interval there. And so do we do everything right? Do we keep the streak? Holy mackerel, what did we do? Did we get the interval wrong? Let me look at that. I had this fuzzy feeling in my head. I shouldn't have fuzzy feelings. Did I do the math wrong? What did I do, Barrett? Wait, 131. That's 12.48. Okay. It's not rounding issue, is it? Just slightly. Okay, wait. 131 divided by 1050. I'm cheating now. P hat. Oh wait, Q hat. We're going to find out where I went wrong. What did I do? Well, I guess the easiest way, just change one of these. What? What? Wait. No, Barrett, do you see it? And really, it's going to accept that? No. No. It says round to 1 decimal. And that was the issue. It was the round to 1 decimal place. It was mad at me for the additional decimals. I was like, I don't know where I went wrong on this. It was the rounding to 1 decimals. Did I delete the page? Because it was 12.48. Yeah. So the interval we had was 12.48 plus 2%. So was that? It was 12.48 minus 2%. And so minus 2 is this. So I don't know how to do minus 2. And then, so this would round to this. This would round to this. Check answer. We're good. Punch the screen. What? I was like, I don't know what I did wrong. I was like, I swear I carried my decimals properly. If you have a problem like that, I just do it to show you. If you have a problem like that, please email me. Please email your instructor. I make the changes, not saying everyone, hey, Kelly, great to see you here. Great work on everything. Excellent work. Got the new haircut. Got the eye appointment. I'm learning how to do my Pearson. That my Pearson is very picky on those decimals. And look at this. You can go down as low as this, and for some reason it's within the range where it's like, that's good enough. That's good enough. Which means we could probably go in here and see, watch this. Let's try this. Can we redo the problem with another version? It's still going to say 131, isn't it? Okay, watch this. Then we'll do another problem. Thank you so much. Almost wedding time, I know, right? Woo! Almost wedding time. I'm super excited. Kayla, we're going to speed run this problem in seconds, and we're going to do another one here. We're just going to say, and there's Philanthropic, who are asking about Philanthropic. So we got quite a few more problems, but I'm going to take the revenge on this problem right now. Here we go. Okay. So this would be, let's see right here. 95% confidence are we? And so there we go. Oh, I was taking a guess at the interval. Is it really going to be? Well, I'll be. Can't guess it today. It's taking its revenge on me, apparently. The environmental agency. Let's do the environmental agency. Let's do it. I'm just guessing at the interval right here. Let's get serious here and do some environmental agency. Barrett, you get to jump the line right here. Thank you for all those answers. Environmental agency is next right here. Barrett, great work. Let's go check out the environmental agency and not get tricked by my Pearson. Not today, my Pearson. Carry those decimals on the environmental agency question. Here we go. Okay. So this is a sample size question. Not my favorites, but we're going to ace it. So when we do these sample size questions, what is the first step? Everyone should know that first step. What is the first step to any question, especially later in the class? First step, put it in the chat, and I'll do it for you because we got a lot of work to do today. And Brian's got to remember to carry decimals. Remind me to carry those decimals. I'm just doing to see. We should. I'll look at emails after this. Between the next little bit, I'll look at emails. Notation. Kayla, 100 points right there, knows the notation. So when we do the notation, probably the best thing to do is mark every number you see. Start marking numbers. Barrett, tell me one of these numbers, the color of the number, and tell me what it is, and I'll tell you the rest. Tell me one of these numbers and what it is, and I'll tell you the rest. Just pick a number. You should know all of them. I think these are all actually important to this problem. So we have to know all these numbers and what they mean and put a notation for them. So the officer as soon as I can help. Oh, the T-hack? Oh, the T-hack? Yeah. You said that one, would it? I know what that is. Great. Barrett, just destroying it right there. You got this, Kayla. Is that the thing that's the thing we give students, right? To see their knowledge? You'll be fine. That's what I think it is. Yep, that's what it is. It's the stat test in 471. You'll do great, Kayla. It's not for a grade, is it? So thank you for studying for it and practicing up. It's not for a grade, right? I'll show you how I got this in a second. I think you'll have some really good. I'd be interested to hear your thoughts on it and share your thoughts. It can be used to replace final. Oh, cool. Oh, cool. Yeah, then study up for it. I'll be interested to hear your thoughts on it too, and I bet Dr. Petrie would be interested to hear your thoughts on it too, on like what do you think of questions. We're always trying to make it as good as possible and as making sure we show your skill sets. It's basically like, I think it's clear what it is. How to take as your stats matter. That's awesome. The T-hack is basically a tools and techniques for all of your stats degree, like all of your business analytics. It's like tools and techniques in 201 is like, what would you use in this situation? That's what the T-hack is like tools and techniques for all stats. Okay, so that Z-score I got right there. That Z-score, how'd I get it? I went to the David M. Lane. Make sure to go over here to the David M. Lane. And on the David M. Lane, make sure to click the second button right here. Then put in the percent and make sure to do between. Somehow that worked. Yep. It's basically tools and techniques for all those. Hopefully you had a good teacher. I think you'll do great. I'm rooting for you. And so that's the Z-score right there, 1.645. The margin of error is going to be, we'll write it here as 0.03. And then the x over n, what are we going to get with x over n? What are we going to get with x over n here? X over n is what? Oh, thank you, Kayla. That's so nice of you to say. I agree. Great job, Barrett, right there solving. And I think Barrett knows and been practicing. Great job, Barrett. That is p hat. And p hat is equal to 0.22. Now, once we get p hat, you know what we're going to solve for. We're going to solve for q hat, which is 1 minus. So double check on your calculator or add these up and make sure they add up to 1. Because p hat and q hat add up to 1, just like p and q. But these are from samples, i.e. we are doing x over n, which is the amount of successes out of a sample. Now, we're going to use an equation, but we're not going to use all of it. The margin of error, and we should know this instantaneously, is everything after the what? Like, you can just put 2 symbols in the chat, but you have to know this, like, margin of error is this. Like, you have to be able to identify the margin of error right here on this problem, which is the key to solving it in a moment. You have to be like, margin of error is everything after this. Like, whenever you see an interval, we did another one yesterday. We're not using this one, but margin of error is everything where. So you have to be like, oh, the margin of error, that's everything where. And I think I may have fixed the lag issue. I'm totally making it so it happens again, but we haven't had any all week, I don't think. I think 1 or 2 random people have said lag, and I think I fixed it. Above and below. Kind of. Maybe you're saying it's everything right here. That's the margin of error. Once you get to the plus or minus, that's the margin of error. To the right of p hat, exactly, the plus or minus. So it's like the p hat or the y bar in those intervals was the center of the intervals, and then these are the margin of errors. So you could simply write an equation like margin of error equals for either of these. Does that make sense, Barrett? Like, theoretically speaking, like the margin of error of those intervals is z times the standard error of p hat, which is p hat times q hat over n square root. The margin of error of the other interval is t star n minus 1 degrees of freedom, s over square root of n. And that's the one we did at the end of class yesterday. And we'll probably be doing some homeworks on that, maybe later today or who knows when. But these are the margin of errors written out for the intervals. But we're not using both of these. We're using one of these. Now, this problem turns into an algebra problem from here. Great job, Barrett. From here, it's just an algebra problem. So I'm going to do this. I'm going to solve for n. Once again, not my favorite part of the problem. Margin of error divided by z-score equals to square root p hat q hat over n. Let's square both sides. Square both sides. You get the following. Then there's a trick you can do a lot of people don't know. We're just solving for n right now. You can actually flip equations. So you can do z over me. And if you do z over me, this becomes on the other side n, which is now where we want it because we're solving for it. And now all we need to do is times both sides by this right here. And that will remove it from that side. And we get p hat times q hat right there. So this is, I did it pretty quickly today because we're not really here to learn algebra. But that's how you can algebra it over. And you will get the following equation, p hat times q hat over the times the equation z over me squared of that quantity. Now, just be careful when you plug in your values. Plugging in your values, the z for this was 90% confident, I think. Check your z-score. I'm using 90% confident. So your confidence level determines the z-score used. Very important to know for your intervals. That's why we often put a little star on it. And so now we're just going to solve through here by going to 1.645 over, margin of error was 3%. It's entered in as a decimal. Make sure to do that. And then the p hat q hat was 0.22 times 0.78. And that will equal to our sample size. So it just comes down to algebraing this out over here. And just be careful when solving. 1.645 by 0.03. Square that. And then times by 78. Times by 22. And there... What? Something happened. 1.645 divided by 0.03. Square that. I might have did square root or something. Something happened. Yeah, I don't... I'm not a big fan. I don't think we have any questions like this on the test. I'm not a big fan, so 516... I can't think of a test question that really uses this. What is probably the big learning objective of this as you work through a problem? Make sure to round up. I think these questions are a little bit nice, though. They give you a little bit of a leeway. Do round up. I think that might, you see there, it's wrong. Once again, it was 516, but there's a little bit of a leeway. But if you don't carry enough decimals, they put a plus or minus 1 on the answer. So 516 was the answer. But what is probably the biggest thing to know for this problem? If you had to say, this problem, I should probably be learning how to do what from it, which is kind of where we spent a lot of our solve on it, making sure we could do that, because a lot of the problems really boil down to knowing that. I would say a lot of this test boils down to knowing your notation. If you know the notation, it just becomes solving an algebra problem. That's why if you can identify the notation of the problem, yeah, and so once you figure out the margin of error right here, just solving this equation, because if I just give you this equation and then give you the problem, you can solve it using this right here, like the z over the margin of error times p hat q hat. So then you have to know how to get your z, because you might not have the same z as me, and you should know the z is relative to your what of the interval. The z-score used in a confidence interval is always relative to your percent what in an interval. You can see it right there. So that's a good learning objective of this problem. If you think about what are you trying to learn from this problem, the z-score is always relative to your percent what of the interval. Like in 90%, 95%, because then it's going to go 1.645, 1.96. So the z is always relative to your percent what of the interval. So these are confidence. Great job right there, Barrett. So those are kind of key learning objectives to be okay, the z-score controls the confidence. So when it says 90% confidence, I need to go find the z-score relative to that. And those are kind of key learning objectives to then go here and get that. Once again, on the test, we would tell you that. But we also could do theoretical questions like if an interval is more confident, it'll be more precise, true or false. If an interval is more confident, it'll be more precise, true or false. If an interval is more confident, be more precise, true or false. Oh, I got you, Barrett. Don't worry. We're throwing some 500 points here. So you ready, Barrett? I'll show you a good way to check. Great job, Kayla, right there. Good check. Both you 500 points. So if an interval is more confident, it'll be more precise. So precise is narrow, very, very small interval of values given. So if I tell you, let's go 68, 95, the interval is getting what? More confident. Does that make sense? 68, 95. And the interval is getting what precise? 68, 95. I got more confident, 68, 95. And the interval has just gotten what? When I do this, from 68, more confident to 95, the interval's gotten what precise? wider and less precise. So more confident. Great job right there, Barrett. And great practice. Just hearing things like this over and over again, and then maybe doing the motions of like 68, 95, 99.7, because 1 Z-score, 2 Z-score, 3 Z-score. Because we're literally just mimicking the area we cover on the curve. For those wondering what I'm doing, if you don't see it in your mind, I was saying like it's so interesting. Like I see things in my mind all the time, but I know not everyone does that the same way. But I just I see everything as I say it. Sometimes my mind is just madness. It's just Doctor Strange mind right here, just going crazy, seeing too much, phone ringing in the background. Just that's Doctor Strange calling me up. But there's the 68. There's the 95. There's the 99.7. And I think it's really great. This is the last thing I'll say on this. It's I do want to say this. It's everyone has different talents. Everyone has different abilities. I do not have the ability to proofread stuff. I cannot find errors in what I write or what other people write. I had to re-render the Star Wars thing. Kayla, did I show you this? Kayla, do you want to see? We're going to do a real quick thing. Kayla, are you still here? I don't think I showed you this. Do you want to see something really fun and really quick for 475 this semester? If you're still here, Kayla, let me know. And then we'll do a few more problems here. Let's see if Kayla's here. Did you see it yesterday, Bear? Oh, you're still here? Okay. Really quick on... Okay. 2 seconds. Really? Went on the wrong screen. Stop. Okay. Here we go. I don't think... Okay, cool. This is preview, and for people who haven't seen it, I'm going to post it to the YouTube channel on May the 4th. Thank you, Kayla. That's no, I have a lot of fun making stuff, and I used it for a few other things. I made a tool 1 thing, and I made a special congratulations for people thing. But I worked on that was that Tuesday night? I don't know. Nights blend together. That was one of those 1 a.m., 2 a.m. projects. One of those making some time at night and working on stuff. Let's see. Let me see if Terry sent an update. Barrett was asking about the curve. Let's see right here. Oh, that's awesome. One of my students just got accepted to one of my students got accepted to a graduate program. That's awesome. Really good graduate program, too. Not ours, which is all right. I don't see anything from Terry right now. Just kind of looking at, but yeah, I'm super excited. I'll email them back later and tell them that's awesome. I'm very excited. There's so many good graduate programs, and I heard that one of our business analytics students, should we give them special touts? Where is it? 10 torchbearers. Here it is. Big shout outs. We got to give big shout outs right here. Does anyone know? Varun, huge shout outs. I'm gonna disappear in the background so we can give them a big shout out right there. Definitely huge shout outs to them. Business analytics, torchbearer. So great job. Congratulations. Just, I love that they were donating their time, helping out, and I think they even donated their money, it said, or he used his own scholarship dollars to improve process. That's amazing. That is insane. And he's going to go on to dental school at Columbia. That is a top-tier university, and going over to New York. We love some New York here. But doing TEDx, that is so cool. So huge congratulations, and congratulations to all of our torchbearers. Just a great job. There were a few more below him. But so just shout outs to every torchbearer. A big congratulations to them. I was reading over this morning and really just amazed with all of their great work. So congratulations to the torchbearers of UT. We are honored by, one, your academic success, and two, your service to the community. But huge shout outs. And we're partial when someone from business analytics as a torchbearer. You know, we like some business analytics here. That's all I'm saying. We are a big fan of business analytics. And so Adults in High School is the next one. Adults in High School. So let's go get the Adults High School. Adults in High School, we got it. You know what we're going to do here is we're going to go and do some notation. Gotta go, Kayla. Have fun. But since our meeting are tomorrow, would you care to send me Discord what I should work on this week? Excellent. We should, and I'll send you Discord too. We should start getting the time series nature of it going. We might have to do some like summation, counts, aggregates, frequencies over. We should start working towards those frequency graphics. So we need to make some new data sets. For a specified confidence level, larger sample provides smaller margin of errors. That is true. Very good work right there, Barrett. We can do that one next if you want, Barrett. We'll do the Adults High School, and then we could do the True False next. We'll try to do the Adults High School pretty quick. I think it's another. We'll be on that in 5 minutes or like 3 minutes. Here we go. Let's do Adults High School. So we're going to do this one a little quick, and I'll tell you why. Because this problem is another solve for n problem. So I don't find these to be the most beneficial for our studying for the test. It really comes down to knowing your notation. And so we're going to see that we're going to use the same formulas from this problem right here. So let's go ahead and go to a new page. And we're going to take our end goal. So watch was it Philanthropic Organization? We're going to use the kind of knowledge we gained from it to help us on this one. This was the environmental agency, which is in this video. Yep, we'll do some concepts next. So stay tuned for True False next. And Barrett, thank you so much. Really good practice right here. And thank you for practicing, because it's one thing to complete the MyPearson, but, you know, understanding, it's not going to let me copy that. We're literally taking the end goal of what we got last time. So let's bring the real problem we're working on. Here we go. We're jumping into it by taking the equation we wrote, and then we need to know the notation of p hat, q hat. Now, if you're wondering how I'm getting this, see? This was solved last time by reworking the margin of error to solve for n. So what it comes down to is it comes down to solving what is the margin of error. Well, the margin of error is they want a margin of error of 5%. What is 21% right here is p hat, which once we find p hat, that means we're going to find q hat. P hat and q hat up to 1, so p hat is equal to 0.21. Q hat is equal to 0.79. So we know what q hat is, and the z-score is usually where people get stuck. The z-score is going to be relative to 95% confidence, which we've been getting a lot of those today. That is a z-score of 1.96. That is the constant z-score always used for 95% confidence. And we can see that over here by going to the David M. Lane, which we'll put the link for in the chat. And there's the David M. Lane. And if you go to 95% confidence and look how the screen is set up, you need to click the second button. You need to do the area between the values. So it'll tell you the z-score right here. Rock knows. It doesn't matter. It doesn't matter if you pick positive or negative, because we're going to do kind of a plus or minus on this. And in the interval right here, it's just the z-score used to make the margin of error. I will mention this was created from the margin of error, which is everything after the plus or minus. This here is a reworking of the following formula. I'm going to erase it here in a moment, but we reworked everything in this box to solve for n. So you can see everything in the box right here has been reworked into a new equation, and check out the environmental agency to watch us kind of algebra it out into this. We don't use the p hat plus or minus. We just say margin of error and solve for what we need for n. So now it comes down to just plugging in the numbers. Make sure you have your correct z-score. I think that's where maybe students have a 90%, which would be 1.645, or 98, which would be 2.3263. And use the David M. Lane if you're trying to find it, or let me know if you don't know how to get the z-score. So now we go right here and we put in our numbers, and we're just plugging in the numbers from up there, and the margin of error is 5%. And so now we have the z-score of 1.96. Square that, and we get the sample size that's going to be needed. And so let's take, and we're going to carry all the numbers. We're going to round up at the end. These usually have a plus or minus at the end. There we go. So 255. And like I said, they usually have a little plus or minus on them. So 255. 255, and it'll probably give it to me if I said 254. Because it's usually plus or minus 1 on the actual number. Do round up. Do round up. Although I'm showing you there's a plus or minus on this, carry your decimals, do round up, and you should be good. On to some true false right here. Let's do it. Okay, Barrett, great work right here. We'll play classic music. I need to look over the new music on YouTube. Well, I don't get copyright claimed for any of these, so that's always a good sign. Always a little bit afraid when I add in a new song to the mix. But I use the copyright stuff on YouTube that says you can use it. But you never know. Someone might say, no, now my song has a copyright on it that you can't use. So this is the several factors. I got another 21 minutes till my meeting with the student. We did it in 4 minutes. Statue 1, chapter 13. Several factors. Let's go check it out. Here we go. Okay, so several factors can actually impact our confidence interval, and among them are the sample size, the level of confidence, and the margin of error, which statements are true. Now, what's going to really help for this question is if we actually solve it along with it by doing the mathematics. So let's grab a version of it right here and actually draw out what we have mathematically while doing this. It says for a given sample size, higher confidence means a smaller margin of error. So it's just saying you're only changing the higher confidence. So Barrett, what in this interval would change if we change the confidence level? If we change the confidence level, just what letter am I writing would change? And this is good knowledge right here. So although it's just true, false, and you'll probably see the answers here, try to think about what would change in this interval if we're changing the z-score. Boom, Barrett, you know it instantaneously. So if the z-score increases, what happens to the margin of error right here? The margin of error would what? If the z-score goes up, which is higher confidence, means the z-score goes up, the margin of error would do what? The margin of error would do what? So if the z-score goes up, higher confidence, the margin of error is going to do what then? So it says means smaller. It's going to increase. So this is false. There we go. Good stuff. Definitely false, because if the z-score increases, you're increasing the margin of error because it's plus or minus, and you're timesing z-score, a larger z-score. So you're making a larger margin of error mathematically. It just means if that goes up right there, the margin of error goes up. So for a specified confidence level, larger samples provide smaller margin of errors. We can take this right here and just copy it down. There we go. And we'll just bring it right here and do the same sort of work and think about what it means. So on this problem, it says for a given sample size, or larger, for a given confidence level, so we're not changing confidence level, larger samples provide smaller margin of errors. So it's saying if this goes up right here, what will happen to the margin of errors? So if that goes up, ME will do what? So Z right here, ME goes up also. But if the sample size goes up, you're dividing by bigger numbers. You're welcome, Cassandra. Keep out any questions you got, let us know. Yes, this is true. Yep. So this one goes down, and we talked about it in class. We love that. So, yep. And that we did a lot of review, and that's inversely related. So your sample size going up would decrease the margin of error of your interval. So, and as it says, smaller margin of error, that's very true. For a fixed margin of error, these problems I don't love. We usually just ask those first two on the test. Just saying, little teaching to the test moments. For a fixed margin of error, okay. So now we need to rewrite this. ME equals. So the equation has to work out to the same ME. Larger samples provide greater confidence. Okay. So This is where it gets a little bit weird. No joke, these ones first confused me when I first did it. Okay. So if you were to have a margin of error fixed, that means you know what the margin of error is. Like, that's a random number, but it is this. Does that make sense? Like, I'm just saying that's the margin of error. I'm just saying it's fixed at that. That's what a fixed margin of error is. It's that value. It's not changing. So for a fixed margin of error, larger samples provide greater confidence. Well, if we provide a larger sample, think about this. The ME would do what? If the sample size were to go up, the ME, as we just said a second ago, would go up or down. So if we provide a larger sample, the ME would do what? Just saying if we change this is all fixed right now. Like this is meant to equal to this. It would decrease the ME, right? So then we should do what to counterbalance that? Since the ME is going down, we could change it to keep it the same by doing what? So since the ME is decreasing because we're providing a larger sample, we could counterbalance that by increasing the what now. So the counterbalance, since we're increasing that, would be to change the z-score. Does that make increase z? And so this is what it says right here for a fixed margin of error, because this has to stay the same. We're saying, okay, if we increase n, that would make that smaller. So let's increase z because it's getting smaller, so we can counterbalance it. Because these are inversely related. Like increasing n decreases it, increasing z increases it. So if we increase n, it'll decrease it. So we can counterbalance by increasing z to re-increase it. So for a fixed margin of error, larger samples provide greater confidence. That is true. Hopefully, it's a theory question. Not the biggest fan of it because we don't usually talk about fixed margin of errors. First two are much more relevant to what we do and what we talk about. For a given confidence level, having the margin of error, this is a good one. I do like this one. So if you have the margin of error, so the margin of error is z p hat q hat over n. So it says for a given confidence level, for a given confidence, so we don't even need that. I'm not changing confidence. We're talking about standard error now. Having the margin of error requires a sample size twice as large. So you want half of this, which it's still z times that, but the z, it's fixed confidence. So we're just going to remove the z and just look at 1/2 of the standard error. Because if you have half the standard error, then we can see how is n impacted by this. But the problem is, and this goes back to a problem we did previously, you can't just multiply these right here. But you could re-express it as the following. Instead of doing 1/2, do 1 over the square root of 4. What does 1 over the square root of 4 solve out to? 1 over square root of 4, which we'd also write, because square root of 1 is 1, square root of 4 is 2. So this is the same thing right here. Exactly. This is still 1/2. Like this, that is 1/2 just rewritten. But now you can multiply, and we can see, great job, Alea, right there. And if you have more questions, let me know. We got definitely some more time. We got one more on the thing, and I got a meeting in a little bit with a student right here. So it wouldn't take half, or it wouldn't take twice the sample size. It would take what the sample size? If we wanted to have the margin of error, it would take what the sample size? It wouldn't take half to get twice, or to get half the margin of error, it wouldn't take twice the sample size. To get half the margin of error, it would take 4 times the sample size. Because of just the way it works with the square root and the radical, and to figure out the proper n needed. Once again, a bit of an algebra problem. So this is false right here. It would take 4 times. Great job right there, Barrett. So false, true, true, false should be. Should be. And they mix these up. Be careful. Notice how it flipped. Be careful. False, true, true, false. Woo! So hopefully follow along, understand what it means, know how to use the formulas. And once again, like practice and know what the theory is and know what these components are. Like p hat and q hat are the sample proportion and complement. Those do play some role, but we don't really get into it. The closer they are to 0.5, the wider the interval. That is correct. Yeah, but the theory doesn't involve them so much. It's more about the confidence level and the sample size, because those are the things you're in more control of. You can control how many things you sample, and you can control the percent confidence you choose. You don't really control what is your sample proportion. But theoretically, when they're closer to 0.5, it is wider, because 0.5 times 0.5 is 0.25. And the more you go out towards the edges of like 0.9 times 0.1, that'd be 0.09. So it's a smaller interval just by virtue of further out towards the edges of confident, or the edges of proportions. We got one more question on the sheet, so let's go take a look at it. The last question of the day right here is the philanthropic organizations. It might be the last of the day. I've probably got a meeting with a student here at 1:20 or 2:20 your time. And so philanthropic organization, good bit of 201 today. And Alea, great to see you here. Philanthropic organization. Ooh, it's a good one. Let's go do it. Here we go. Once again, and I'll help out right here, but tell me, what do you need to know to solve these problems? To solve these problems, you need to know your what. You have to know your what to solve any of these problems. Gotta know it. What do we have to know? Very important thing to know for any of these problems. If we don't know it, we're like,
It doesn't matter.
Rock, it does matter. We have to know it. Frank, great job right there, 100 points. The notation. Oh, you're welcome. Go enjoy a sandwich. Have some fun time. Enjoy, and thank you for the wedding. Good practice, Barrett. Barrett, let's throw some 500 points. Barrett, great practice today. We're just here practicing the material, learning the notation, and glad you learned a lot. We talked a lot about confidence rules and how they work. So really good practice, because those matter for... Rock always telling us things don't matter. Those matter for a lot of the chapters we're doing. Who can tell me what the 90%? We'll need to look up the what for that. I'm going to solve this out right here. That's the number of successes out of the sample. 90% is going to be how I'm going to find the what for the interval. 90% is going to be how I'm going to find the what for the interval. This is p hat, which is the sample proportion. So it's this. 90% is how confident I am. Brian, go find your what for the interval. Because whenever I say percent confident for a proportion interval, I need to go find my what. So when I say I am this percent confident for a one prop z interval, I need to go find my what score. I need to go find this. And that's p hat. So q hat is 0.95. Brain, what you doing? 143. I think so. Z score, Gwendolyn. Great work right there. So we're going to go to the David M. Lane applet. I'll put it here in the chat. And excellent work. Good practice, Gwendolyn. And so is it 90? Is it 90%? 1.645? I think it's that right there. That's 90%. So make sure, once again, we'll show people again here. Go to the David M. Lane, click here, click your percent, and then make sure you're selected between. You should see the middle portion shaded. And once again, we will give this to you on the test, so we don't expect you to memorize it. But knowing that z-scores come from the normal curve, and it's the percent, we're going out symmetrically on either side because we're covering the middle 90% of values. And the z-score relative to cover the middle 90% of values is 1.645. So that's what we use down here in the equation when we write p hat plus or minus z-score square root p hat q hat over n. And it really comes down to just plugging in the numbers and just making sure to do your math correctly and rounding correctly at the end, as we found out on the first question today. So make sure to round and carry decimals. If not, you will have problems. The z-score was 1.645. And now we need the square root. Points. Barrett crushing it with those points all the way up there at StatNation Mubot level.
I am Mubot.
Thank you, Mubot. He can talk. Oh, that's the fun music. I like that music. 9.5. There it is. Josiah Wilkinson playing the piano right there. Thank you for never hitting us with a copyright claim. I'm just like thinking one day he'll see on his channel like, you have 50 occurrences of Stat 1 using your music. And then someone will be like, let's copyright claim the heck out of them. My whole channel will fall apart. And I'll be like, Josiah. I don't know. I don't think he would. For us playing that 10-second riff of Coldplay. Thank you, Josiah. Okay, so that is the margin of error right there. Very tiny margin of error. Once again, I just solved through the equation right here. P hat times Q hat over n square root times the z-score to give the margin of error. And so 1118. Cool. All right, it's a little tiny. I guess so. Yeah, it's only 90% confident. Yeah, I guess so. Huh. Okay, let's time that by 100. Cool. I guess so. Cool. There it is. Good to see you here, Mitzi. We got time for another quick question or so. Maybe. I have to talk theory-wise. So let's take the center of the interval, which is 4.857 plus 4.97. And then the center of the interval, which is 4.857, subtract 4.75. Let's hope we get the last. So is 4.9 plausible? You bet. It's in the interval. That means it's possible. I am 90% confident that the true proportion of people who respond to the Philanthropic's organization mailer is contained in the interval 4.75 to 4.97. Reason it's so small of an interval is because the sample size is very large and we're not doing a high level of confidence. This theoretically makes sense, and we did get it correct. Larger sample size leads to a smaller margin of error, and smaller confidence leads to smaller margin of error. So it's kind of fun to, especially if you understand the theory behind it, we could retry the Philanthropic to see if we can just guess it, which is always a little bit fun here. We'll end off here on some guessing games. We'll see how many of these we can guess. Can we submit the quiz? Okay, let's do this whole quiz. You ready? We're going to guess the whole quiz. How do we do? Oh, well, this one's a long one. We don't want to do that. That's a bunch of... We did that, I think, a few days ago. Here we go. 99. Ooh, 99% confidence? Well, that's very hard. Well, that's going to be within the 99% confidence interval. If you have questions, let me know. We're just guessing through the whole quiz here at the last 5 minutes of office hours. So let's say guessing the whole quiz. Put a timestamp here. Guessing the whole quiz. All right, let's do it. So how good can I do? The 99, of course, they're going to go to a ridiculous interval. Okay, so that's the center of the interval. So let's just go symmetric around it. Let's go symmetric. Because that's 4.5% about, and I'm going symmetric up and down. I'm guessing the margin of error is 0.2%. So that's a guess on that. Vitamin D deficiency. So 24%, so I need to go symmetric around that. Let's guess, so it says a decimal. So we're going to guess a symmetric interval around that with a margin of error of 2.5%. We're just taking guesses. We're just having some fun. Well, here we can make our lives easier. 24% symmetric, 3% up and down guess. We are 98% confident the true proportion of children who have vitamin D deficiency. Explain what it means. 98% of 90% confidence contain the true proportion. Sample size for this one. Remember, we're just guessing the whole quiz right here. 95% confidence with 2% margin of error. This is near impossible to guess. 560. That is, if I get that, that's amazing. Once again, this one's near impossible to guess too. So let's just guess 560 because that's going to be super hard to guess. 99% confidence. Environmental should sample at least this many vehicles. That's a big confidence, so we need a big number. Man, there's so many solve for n problems. If I get a single one by guessing, that'd be beautiful. Probably not. 95% confident with that, and so we're going to go symmetric up and down to about 4.7, making it easy by doing a very symmetric interval around this. Is that within it? Well, it's within my interval there. So I'm going to do horrible at this quiz. 95%. Oh, we haven't done this one. Oh, no, we haven't done this one. 88, so that's... I'm using no calculator, pure guesses. We are 95% confident the true proportion of... Is it adults? Accidents involving teenagers, yeah. 95% will produce confidence intervals that contain the true proportion. To restrictions, the confidence interval does not contain the assertion. It's outside the interval. Okay, cool. And so... We're not using any. So 12% to 18%. I'm trying to think that one in my head. How do we do 1,015? I think this is the last one right here. Oh, we got two more. And then going over to meeting. Just guessing the whole quiz right here. 90% confidence interval. With that many flyers, they get orders from 100. So that's less than 10%. So we're going to go 7 to 11%. Just a guess right there. The company is 90% contained within the interval. About 90% of samples will produce intervals that contain the true proportion. Oh, I didn't complete all portions. They want to get at least 6%, so they should do the mass mailing. Did they change this one? I don't know if they do. We're literally okay. Oh, wait. One could be 900. Yeah, that's right. Apply certainty. 81%. Yeah. Oh, wait. No. One can be 9%. Yeah, that sounds right. Reading them very quickly. One is 95% sure that's. No. We know the sample customers. We know that. On 95% of days between time. No, it's about the parameter of interest. Yeah, it's about the parameter. Okay. Woo! Well, we just spent. I know. I like it too, Mitzi. It's just we had a few minutes, and I was like, let's see. So once again, please note this is all guessing. It's just me going as quick as possible, barely reading it. How do we do? So we got those first ones, which I knew. Look, these were all the ones with the. We got a 50 in 4 minutes. Wow, that's a lot. So we were going very quickly. In 4 minutes, we got a 50. So some of them, we got some more than others. The ones with these were all the ones where you have to do the self-ren. Man, there's a lot of self-ren problems. But the ones where you have to know the true false or the other portions. But that was pure guessing, 4 minutes. But once again, if you want to do them seriously, please do them seriously. That's the best I could do, guessing through. And remember, as we do this, we've solved these out earlier, solving all the notation, marking it down. Brian got a 53. So I was like, how high could I get? I couldn't pass it guessing through. Some of them I can guess, some of them I can't. It just depends. Like, guess the sample size. I'm like, let's take a look at one of those. How close was I on like question 5, which is going to be different every time? 560. Yeah, that's so hard to guess. 560. Yeah, it's just very hard to guess that. But that's a tough one. Well, if you heard it, there's the time for the meeting. We'll be back here doing some class here in 30 minutes. Until then, bye for now, everyone. Bye. Let me know. We'll do off stairs later if you have questions.